If you want your PC to be cool, you need to have fans. For most users, they're not that important because they rarely have a noticeable impact on the everyday performance. However, if you're running a high-performance PC or you want your PC components to stay cool even under heavy loads, case ventilation becomes critical. In this video, you'll learn about the most overlooked component, the PC fan. I will explain you the different sizes, connectors, bearing types, materials, and other key characteristics so you'll know what to look for when choosing one. So let's begin with the common labels that you might encounter when searching for a fan. CO means continuous operation. These are fans designed to run for long periods without defects. PWM stands for pulse width modulation. These are 4-pin fans, which I'll explain later. PST refers to fans which include an extra female connector, allowing you to daisy chain multiple fans and control them through the same motherboard header. Slim, fans that are thinner and can fit in tighter spaces. AF, optimized for airflow. SP, optimized for static pressure. RGB and ARGB indicate fans with integrated LED lighting. The most important parameters to look for are the following. Rotational speed. Higher RPM usually means higher maximum airflow, but fans spinning faster tend to be louder. Smaller fans generally have higher RPM, while larger fans spin slower, making them quieter. Airflow, the amount of air that passes through the fan for a certain period of time, usually measured in cubic feet per meter or cubic meters per hour. Higher airflow means that more cool air is moved, but this often comes at the cost of increased noise and reduced static pressure. Larger fans naturally move more air, which is why they often have higher maximum values. Some fans are specifically optimized for airflow, featuring fewer fins and larger gaps between them to allow more air to pass through efficiently. Static pressure, the fan's ability to push air through obstructions like heatsink fins, dust filters, and meshes. It's measured in millimeters H2O. Fans optimized for higher static pressure usually have more blades, smaller gaps between each blade, tighter spacing between the frame and the blades, and a steeper blade angle. Noise level. This indicates how loud the fan is. It's measured in decibels or zone. The two units aren't directly comparable. Decibels are more scientific, while zone is increasingly used by manufacturers because its linear scale better reflects how humans perceive loudness. Fan size, usually stated in millimeters, referring to the length of the fan site. Most PC fans are square, with common sizes being 80mm, 92mm, 120mm, and 140mm. Larger sizes such as 200mm exist, but are less common because they are harder to fit in most PC cases and require more durable parts to support the extra weight. Nowadays, 120mm are the most popular choice, ideal both as case fans and for coolers, while 140mm fans are typically used in larger cases. Bearing type. The bearing sits between the frame and the drive shaft, allowing for smooth rotation with minimal friction. They determine the fan's suitable mounting orientation, longevity, and noise. There are 5 common types, and now we'll explore the advantages and drawbacks of each. Ball bearings are very durable. They can handle high heat, work in any orientation, and have a long lifespan. However, they are noisy by design and tend to get louder over time compared to other types. Dual ball bearings use 2 rows of balls for extra durability and are most commonly found in servers and industrial equipment where reliability is more important than noise. Sleeve bearings are the simplest and cheapest option, usually found in budget fans. The shaft rotates inside a lubricated sleeve. They are quiet initially, but heat and centrifugal force push the lubricant away from the friction surface, which causes faster wear. Sleeve bearing fans must be mounted vertically, because if they are mounted horizontally, the lubricant will escape more quickly, leading to premature failure. They are usually serviceable, and you can add a few drops of oil if they start squeaking. Rifle bearings are an improved version of sleeve bearings. Tiny spiral grooves are added inside the sleeve, which pulls the lubricant as the fan spins, giving them longer lifespan and allowing horizontal mounting. Hydraulic or fluid dynamic bearings take the rifle bearing concept even further. Special grooves and oil pressure keep the shaft centered and well lubricated. Fans with FDB are very quiet and durable, but are also more expensive. Usually they're sealed and are not serviceable, so you cannot add lubrication. They're commonly found in high-quality CPU coolers, premium PC cases, and GPU fans. Magnetic levitation bearings are the most advanced type. The shaft is surrounded by magnets and held in place by the magnetic field. This makes them extremely quiet and durable, with the ability to outlast all other types. These bearings are only found in premium fans and are more expensive than the others. Of course, the bearing type isn't the only factor that affects the fan's performance. The materials used for the frame and the blades also play a crucial role in durability, heat resistance, and vibration dampening. Most budget fans use ABS, a cheap and lightweight plastic which is easy to mold, less rigid, and more prone to deformation under heat. PVT is more common in mid-range fans. It's stronger, can withstand higher temperatures, and maintains its shape better under high RPM, which helps reduce noise and vibration. Liquid crystal polymer is even more durable and is used in high-end fans. Its strength and thermal resistance allows the blades to maintain very small gaps to the frame, even under high centrifugal force, improving static pressure and efficiency. Depending on the connector, fans come in 3 types: 2-pin, 3-pin, and 4-pin. The 2-pin fans are the simplest, with just a positive and a negative wire. They're mostly found in cheaper PSUs and cases where the fans run constantly. Their speed can be reduced by lowering the input voltage, but there's no way to monitor RPM, and since minimum voltage depends on the model, lowering it too much can make the fan stop spinning. When used as case fans, they may also be hooked to a Molex connector to draw power directly from the PSU. The 3-pin fans have a third wire, a tachometer signal for monitoring RPM. They're designed for voltage control, which lets you set a custom fan curve based on temperature. However, lowering the voltage too far can still cause the fan to stop. The 4-pin fans, also known as PWM fans, add a control wire that carries a rectangular signal from the motherboard to the fan's internal circuitry. The duty cycle of this signal determines the speed. If the signal is high 25% of the time, the fan runs at quarter of the maximum speed. At 50%, it runs at half speed, and if it's constantly high, the fan runs at full speed. Because they receive always 12 volts on the positive wire, PWM fans allow for more precise speed control and can run at lower speeds without stalling. Last but not least, let's go over the brands. The most reputable name in this field is Noctua, known for high-end fans that deliver durability, high airflow, and low noise. Other trusted brands include Be Quiet, NZXT, and Corsair. For budget-friendly options, Arctic and Deepcool offer solid solutions, with Arctic's P-Series deserving mention for their impressive performance and quiet operation at a low cost. Thanks for watching. If you enjoyed this video, press the like button and subscribe to receive more similar videos in your feed. As always, feel free to share your thoughts in the comments below. See you soon!